Hi everyone, welcome back. My name is Eileen Chevalier and I created Eileen Chevalier's typewriter alphabet. These are the flashcards. So today we're going to do a botany lesson on more or not roots. Not everything that grows underground is a root. Many plants have special stems and leaves that are mistaken for roots. In this lesson, we'll take a closer look at bulbs and their spectacular roots. So for today's lesson, we are going to use the flashcards as well as the DK Ultimate Visual Dictionary and the Smithsonian Flora book. So go ahead and get those and definitely get your journal, because the first thing we're going to do is some definitions. So I will read to you and you can write it down, okay? Bulb. Underground basal plate stem attached to the scale leaves that store food for the plant. Ready for some questioning and investigating? First up, the basal plate stem is like a stiff pancake with scale leaves attached to it. When conditions are right, roots emerge from below while leaves and flower stems grow from the top. Cut open a bulb. You probably have an onion sitting around. That's a bulb. You can just slice that in half and examine the basal plate stem. So it's going to be the hard, if you look at the bottom of the onion, usually you see a little few dried up roots maybe, but that really hard bit that's right there at the bottom that you don't eat, that's the stem, or the basal plate stem is what it's called. How is it similar to or different from other stems? Do basal plate stems have the same job as other stems? So are they still providing structure for the plant? So all of the scale leaves that are attached to the bulb, and then later on the roots that are attached, and all of the vegetation that comes above the ground, is it still all the structure based on that basal plate stem? Is it still holding everything together and providing structure for the plant? Is it still providing a way for the fluids to get transported through the plant? So think about how it compares versus other stems. You might want to go back to the other stems lesson and look at your notes, and kind of like a basal plate stem is different from most of the stems that we think of, right? So just do a little comparison, size, shape, texture, but also purpose. Like, what is it still doing the same job? Does it have an extra job? So think about that. And then, how do most stems survive? How is the survival of bulbs different? So think about what happens to a stem over the course of a year. And there are so many different types of stems. So again, you can go back to the stem lesson and think about those. So you've got tree trunks. That's one type of stem. They function very differently than other types of stems. So if you have a deciduous plant, for instance, what is that stem, like how does that function differently? Or if you have a perennial that's like a bleeding heart, it all dies back. So all the stems that you see above the ground are dying back in the winter. And what's happening to those? Is there still some remaining stem on the bottom that's sort of like a basal plate stem? So think about how different plants survive and what makes their stems able to withstand winter or disease or predators, all that sort of thing. Next up, read about contractile roots on pages 36 and 37 of Flora. What makes a contractile root special? They're really cool. Why are the roots of a bulb the contracting type? What are the advantages of having contractile roots? Try buying bulbs at a store and planting them in rocks in a glass container. I love this. This is super fun. I'll see if I can find some pictures of when I did this. Do the roots try to contract and bring the bulb lower into the vase? Why or why not? So think about what the job of a contractile root is and how that job might be different in your house than it would be in the ground. So a lot of times plants do things for particular reasons in nature, in their natural environment, and then we move them inside or we put them into an environment that's not natural to them, and then they're functioning differently than they would if they were in the environment that they have been in nature, right? So we're putting them in an unnatural environment. Do they behave the same or do they behave differently because it's a different environment? So let's look at those pages in Flora because it's pretty fantastic. All right, again, gorgeous illustrations. Highly, highly, highly recommend this book to you. Contractile roots. Roots provide anchorage for plants, keeping them in place through whatever the weather throws at them. But some plant species can actually shift their position in the earth using specifically adapted roots. Contractile roots pull a plant deeper into the soil by shrinking and extending. So think of like worms. It's kind of the same. So they're like pulling themselves along through the soil. They are commonly found in plants with bulbs, corms, or rhizomes. So those are all modified stems, okay? Contractile roots also occur in a variety of other plants, including those with taproots. By plunging into the soil, contractile roots provide greater stability and ensure that maturing bulbs reach the right depth. So I'm going to show you this picture again down here. So you can see that the roots are continuing to pull the bulb deeper as the bulb grows, which is amazing. So what I was saying about growing bulbs in water, which is just really cool because you get to see the roots emerge and how they look through the glass. So in nature, the roots would be pulling the bulb deeper into the soil to protect it from freezing temperatures. So is that going to happen in your house if you have these bulbs? Also, think about the medium in which they're in. So the medium is just kind of like the material, right? So if a bulb is in dirt, the way that a root moves through dirt is going to be very different than the way the bulb moves through rock. Because of how often it's touching, the amount of water versus the amount of solid material, it's all going to be very different, right? So, but watch and see. Is it easier for the plant to pull itself down? Does it? Do maybe different types of bulbs still use that contractile action so they're pulling themselves in, or do they all just kind of sit on top and let the roots go down into the water and then grow? So, fun little experiment. Again, I'll try to show you a picture of when I did it, or if not, it's been a long time since I've done this, and so maybe I'll just buy some more bulbs and do it and do a future video on that because it's really, really fun to see. I'm going to read one more little section to you. Hyacinths and many bulbous plants live in seasonally dry regions where spring rainfall is followed by long summer droughts. So think about where the bulb is and how much water it's getting and what those roots would be good for or not good for. Remember when we talk about leaves, we're like, how much is it costing the plant and how much is the plant gaining from those leaves? Contractile roots pull bulbs deeper into the soil where temperatures are cooler and where they are less vulnerable to desiccation. Desiccation is drying out. Spring flowering bulbs remain dry throughout the summer, and their roots may shrivel entirely. So think about when you buy a bulb at a store, it's dry. There are no roots on it. You might see like the remains of little roots, but it's really dry. And you're like, how's this thing alive? But they are designed to do this, right? Like that's how they protect themselves. When winter rains arrive, the roots regrow and the plant is ready to flower the following spring. So it's signaled by its environment. Okay, now it's time to stop working on those roots. We're just gonna be in storage mode. So it goes into this like sort of a hibernation period, right? So it's hibernating, and then when the conditions are right and there's rain and the soil, it's really hard. If you've ever tried to dig in dry soil versus digging in soil that has a lot of moisture in it, you will know that digging in soil with moisture in it is vastly easier than digging in really dry soil. Same thing with the roots of the plant. So for the plant to put out roots when it's very dry versus for the plant to put out roots when there's that rain and there's the moisture in there. So it's just responding to its environment. And then I want to tell you one more thing about the roots, because there are these contractile roots and then there are also feeding roots. So contractile roots work by shortening some of the cells of the cortex and widening others. So they're like expanding and contracting. Feeding roots sustain the plant throughout the growing season, but most die back after flowering. Some feeding roots thicken and develop into contractile roots as the bulb becomes dormant. So there are multiple kinds of roots and they have different jobs at different times, which is pretty amazing. All right, so let's look at what we are going to do for journaling. The first one is to do a section drawing of a bulb, preferably from a bulb that you've cut open so you can examine as you draw it. So you can do that, like remember in the investigating section when we actually cut open an onion and looked at it, you can use that same onion and just do a drawing of it. See if you can find the stem that will hold the flower. That is called the peduncle. And so this is a really good one. Sometimes onions kind of sit around a little too long, or like you forgot that you put them in that back corner of the cabinet, or like under the whatever, and then you come out and you realize that they've already started like kind of sprouting a little bit. So those would be perfect for this activity because you can actually see how the stems are starting to grow out from the basal plate stem. Sometimes you can even see an immature flower. So that's what happened when I cut open a daffodil bulb. It was phenomenal. I bought the bulbs like later than you're supposed to buy them and plant them. So it had already started developing in anticipation of all of those, the rain and the water and the warmth. And so it was already going because it knew that those conditions were going to be correct. So that's a pretty cool example. Make sure you label your pictures, and if you don't have a bulb yourself, you can watch the dissection video when I cut open the daffodil bulb and show you all the parts of it. I also have some pictures, so I can show you my pictures as well. Next up for journaling is to title a page in your journal, Not Roots, and collect names, pictures, and illustrations there of plant parts that may look like roots but aren't. Label with the plant part they actually are. See if you can find examples of both stems and leaves. So if you're doing these bulbs, you're definitely going to have examples of leaves that are growing underground, right? And then you'll probably keep finding these as you go along, especially so then the lesson that I plan to follow, you might have already done it, is called More Stems. So we're going to talk about some other things that people think are roots, but really they're stems. So that's a good one for you to go back to this page in your journal and add some more information to. All right, guys, I hope you enjoyed that. Contractile roots are super cool, and being able to cut open bulbs and look at them, you'll never look at an onion again once you understand the basal plate stem and the scale leaves. So enjoy your newfound knowledge and keep exploring, and I'll see you next time. Bye, guys.